So welcome you guys. Thanks everyone for coming. We're really excited to have you here. I think a good number of you are familiar with Madrona, but for those who aren't, we're a seed stage investment firm. We focus on technology startups here in the Pacific Northwest. We've been around for about 20 years. This whole thing is about creating greater engagement with the technical community. We really want people levels of engagement and to provide as much value to you guys as we can. Obviously, we're involved in a lot of technical startups, which you'll see all these companies are companies that we're working with and trying as much as we can to help grow and support and all that. So yeah, apart from the technology stuff, we're always interested in ideas. So if you're working on startup ideas, come and talk with us. If you're more interested in the companies, come and talk with us, all that kind of stuff. So what I'll do, we're just waiting for one more panel. Diego, I'm grabbing a last bite. But I think we can probably just go ahead and start with introductions. So for the introductions, let's go with your personal background, your company and what it does, and define data science. You didn't tell us that.
So my name's Dustin Hillard. I'm VP of Engineering and Context Relevant. So I lead all of our data science and engineering efforts there. My personal background, I did a PhD in electrical engineering, which was focused on machine learning, but applied speech recognition, natural language understanding, and machine learning, basically. After that, worked at Yahoo on search ad ranking, and Microsoft on Cortana, which is a lot of you probably know, and others that don't. It's basically the Siri style of natural language understanding. Joined Context Relevant a little over 2 years ago, and what we're focused on at Context Relevant is providing machine learning to businesses. And so what differentiates us is that we focus on product organizations at businesses, so we're delivering applications that kind of deliver end-to-end scenarios, less of a data science platform and more of how do we solve your business problem using data science, so lowering the expertise and time barriers to delivering these things. And a quick definition of data science. It's a mess. someone that can clean up a mess and do something to make something useful.
Hi, Elliott Waldron. I'm Director of Analytics at another Madrona company called Placed. And my background is cognitive neuroscience, mathematical psychology. Let's see, out of school, I jumped into the startup world. Another Madrona company that I was with was called Faircast, where we developed kind of the first prediction of directional airfare prices. So it was really fun. I really like working with new data sets that nobody has come across. And Placed definitely has one of those. We have a high-frequency location panel, so folks run our app on their phone. A couple 100,000 people per day are running the app, and we collect billions of location data points from them and make products from that data set. So being able to have that kind of data set is a really exciting opportunity for data scientists for us, and we're all really having a good time with it. Data science. I don't know. I think it's the just application of the scientific method to solving a business problem. I think that's fundamentally kind of what it is, and then there's lots of ways to go about doing that at a high level.
That's a really hard question. Even though I'm like the third person in the room, I still have no idea. But I'll get started with a bio. My background is in machine learning. I graduated from UC Berkeley, I'm a Cal alumna. And I was in CMU for postdoc, and then I was at Microsoft Research for 6 years, and joined GraphLab last year. So GraphLab is a data science platform, so we are more on the platform side. We're building tools for data scientists to take their ideas from inspiration to production. So we make that whole pipeline more smooth and less frictiony, so that people can do ETL and build good, sophisticated machine learning models and visualize results and visualize the data, and then finally deploy the model, build predictive applications on top of it, all within the same system, within the same platform, so without switching between different back tools. That's the goal. So that's also Madrona company, and you guys have
Obviously.
Obviously. Data science, I think of data science as coming up with gold in a pile of mostly useless data. Or I guess analyzing and modeling data so that they yield insight about whatever problem I'm in. High level, very vague definition. There you go. Good luck.
Hi, my name is Diego Oppenheimer. I'm the CEO of Algorithmia, another Madrona company. You can see the name here. So my background is I did my undergrad and my master's degree at Carnegie Mellon. So my specialization there was big data analytics, business intelligence. I was actually more on the business side always than the, you guys are way more scientific than I am. So it's easier, harder to find data science. So what Algorithmia does is we're a marketplace for algorithms. Essentially what we found, I worked at Microsoft, first worked actually on investment banking on a trading floor. I was doing data analytics on a trading floor. From there, went to Microsoft, working on a product that you probably all have used at some point. Might hate me after that, it's called Excel. So I was in charge of defining like the features that connect to big data sources or databases, visualizations, pivot tables, stuff like that. And then one of the things that we found there was constantly looking for new algorithms to kind of look at through data and say, oh, this data can be shaped in this way, or this data can be shaped in this way, and suggesting that to business users who have no clue what they're doing. If you look at from that perspective. And a lot of that comes from research. So what Algorithmia does is actually provides a marketplace for researchers in the algorithm space to come to our platform, upload their code, we deploy it through our API, scale it in on-demand infrastructure on multiple clouds, and then anybody can use it. And so it's really getting that research in academia and to be able to make it out to the world, which most of the times there's one PhD here, how much of that work just dies on a paper and nobody ever gets to use it. Even though it might be like really well changing. So that's what we do. The definition of data science, I'm going to take a slight different angle on it. I'm going to say, I would say it's the systematic elimination of the business hunch. For so long, anytime you'd go to a business and be like, well, my hunch is that we should sell this, or my hunch is that we would do better that. And what data science is allowing is for that entire phrase to just go away. Now we can actually go and say, well, let's look at the data, and using scientific rigor, we can actually go and say, well, this is the way it is, or that is the way it is. So that's my personal definition of data science. Is that
cool? I think I can project this hopefully well enough. Actually, my first question, I want to start with you, Alice, because you're doing a platform, and you guys have interacted with a lot of customers across domains and stuff like that. Right now, how pervasive are you seeing the use of data science and application of these tools and techniques across industries? And are there like key industries where it's really heavily being used in?
So that's a big question. You guys don't ask small questions. I think different industries are at different stages of adopting modern data analytics. I think everyone across the board is using business analytics. Excel, very popular, very useful for a certain class of analytics. But I think nowadays people are pushing more complex analytics. So things that take longer to, models that take longer to train than say coming up with the pie chart of distribution of sources of revenue, or customer segmentation by handcrafted rules. So I think the modern machine learning algorithms and modern data analytics are more complex. They're both more complex to use and more complex to develop. And so there is an adoption barrier. And I think the first wave of adopters are tech companies with a lot of resources. You can hire experts in algorithm and machine learning development and algorithm and experts in system engineering to put everything together to build these big platforms that serve that are very high bandwidth and serve a whole bunch of queries all at once. But everyone else is trying to revamp their the way that they're handling data analytics. And even if they haven't started yet, they've heard of terms like big data. So there's very widespread interest across industries. But I would say that the tech industry, and in particular large tech companies, are the first wave of pioneers, and other people are at different stages of being able to acquire in-house expertise and being at different stage of data readiness. I think a big problem in getting started is the data is kind of siloed and stuck in different corners of the companies, and it's a big effort even to just aggregate the data into one place that can be useful for learning more advanced analytic models.
So there's a couple questions. I might get a little ahead of myself that I'll come back to about challenges and so forth. But we had a great question that was submitted by the community group here, and I kind of want to ask you this, Dustin, because you guys are doing some really, really advanced stuff with machine learning and so forth. So it's the concept of a big data winter, where Michael Jordan of Berkeley predicted the big data winter, which is basically an overpromise and hype around big data, and people not really understanding what's actually feasible. And I just wanted to get your opinions on the validity of that concept.
Yeah, so he has great points, many of which could, I think, be part of our, should be part of our marketing, essentially. So a lot of the skepticism he's raising is a lot of what we're, and actually some of the points he raised were around, there's a lot of engineering and science effort that needs to be productionized, basically, right? It's in academia, but it's not then kind of made robust enough for business. And so a lot of what we're seeing and talking to customers is that like their C-level people have heard big data and need to do something, it's critical to your business. And a lot of what that has instigated is adoption of Hadoop. And mainly, so what they've kind of started to solve is this data silo problem, right? So they've gotten Hadoop and they brought all their data to one place. But it's not, then they're not really, the next step of building an application on top of Hadoop is the thing that the tech companies are the only ones that have been extremely successful at, because they've had huge investments. Like to build applications on top of Hadoop, you need someone that's, an engineering team essentially, basically, to be successful at using that distributed system, and then a bunch of smart data scientists to frame your problem and work through. Hadoop is a pretty slow tool at this point as well. So it's a very long iterative process. So I think it's a large risk, this big data winter issue, because he's identifying that people have not very great tools to do this. So there's kind of this premise that once you get Hadoop, all your problems are going to be solved, right? You'll have your data and you can know where you're going to uncover the gold in all your garbage. And that's really not realistic. So I think we're finding that adoption of NoSQL is kind of sometimes a stand-in for big data technology, and that really just allows you to run more fast queries over the data. That's not really the predictive or understanding or extracting insight portion of it. And on the other side, places like Tableau have done great things, and Excel for visualizing data, right? But they're still kind of dependent on generating the right query to find the value. And so that's still that kind of iterative slow process. So this big gap in the middle is technology that actually distills your data to something that is understandable and you can make actionable decisions on and measure those. So the other valid issue he's raising is this idea of generalization. Once you build a model, I think the other thing that we've seen a lot of organizations, data science right now is built around SAS and R and these kind of tools. And so they definitely have, you can do modern machine learning in them, but they tend to be more simplistic linear models and these kind of things, and less about cross-validation and held out sets that are really testing how is this going to do when I deploy it in production? Am I going to make good business decisions? And that's a lot of the risk, right? Is without a lot of sensitivity analysis, you have high risk, and it's something we deal with a lot because we're primarily focused in finance now. So there's large downside if you make the wrong decisions, right? So understanding the sensitivity and risk associated with the predictions is a big piece of that. And so having that be robust is, I think, the main point he's raising, because that's critical to not
and so that's like a great transition into tools and so forth, but I'll come back to that. So the actual question that was asked was based on that, but what about the reverse? Are there things that sort of the business side understands about building a business around this space that maybe data scientists and engineers don't? And I think maybe let's start with Diego on that.
So going back to kind of like when business, around a number of years, when business intelligence started becoming like really popular, really the promise there was, and I saw it like firsthand kind of when I fell in love with it, was you go in on a sale to like for a business intelligence tool, and you go and you could with a straight face go and tell a CIO or CEO, I'm going to tell you something about your business that you don't know, but it's all past looking, right? And that was and I mean that was a lot of hype. You could sell to businesses that way because you say, exactly, I'm telling you things about your business, not even you know. With the whole world of big data, and especially with like kind of like predictive analytics moving forward, it was like, I'm going to tell you something about your business that you don't know, but nobody else knows either because it's in the future. And that's how it was sold, right? And that's how like the marketing engines of going out and selling this went out and selling it, and so everybody wanted to be a part of that without understanding at all what that means. So you could use the analogy that's used a lot. You're giving a hammer without a nail, and so people are swinging around this big data hammer left and right and don't really know what to hit with it. So the tools becomes interesting because the tools are really, really advanced right now, and they're getting easier and easier and easier to use. Yet the biggest gap that I see is the education gap of the people using the tools, right? So suddenly you have people who are like making all these assumptions around like what the data's saying because like, oh look, I see a graph that like shows one number bigger than the other, yet they don't understand any of the statistics behind it. So the tools keep on getting better and better. Just now, I start seeing the education kind of started catching up. That's really, in my personal opinion, the biggest gap we have right now is that the people using the tools have no idea what they're using.
And so
that was a big part of that, I think, self-blame there.
And he has great stories about Excel customers. So I want to jump over to Elliott to get a little bit more specific around tools, because you guys are solving very specific problems, not as much of a platform, although I'm sure you have some sort of reusable stuff internally. But what are the tools that you guys are actively using? And maybe you could talk a little bit about some of the business problems and the specific things that you're working on.
Sure, yeah. We're kind of tool agnostic, I'd say. I mean, we use everything. You come to our office, there's 16 people, 5 of which are data scientists. And we work on problems kind of in the research phase, kind of independently. Most of us use Python, some use R. We have a guy who's using Ruby too. So we try and, at least at this point in our stage of evolution of the company, try not to put a stake in the ground and make people use a certain kind of tool. We also are kind of, because we're so small, the data scientists do some of the production coding, which is unfortunate sometimes, but because there's just limited resources to get stuff into production, we're called upon to do that. So the requirement really for a data science job at Placed is that you can program and as well as do analysis. But mostly what we do is, we just kind of use the modularity of Hadoop and MapReduce to you just write the little components, the mappers and reducers, and kind of away you go. And that can be in any kind of language that's supported on the instance. So everything's run on AWS, and we solve all sorts of problems using that style of analysis. I think about from the raw location data that's collected off the phone. There's analysis that's done to cluster those data points into commercial business visits. There's analysis that's done to turn those clusters into predictions about where somebody is at one point in time. There's all of the analysis associated with merging information from the point of interest databases and the deduping, natural language processing kind of analysis that's done there. After that, there's all the normalization that happens. There's predictions. There's 20 models that make predictions about whether somebody, based on the apps on their phone, is a male or in a particular age group. And then finally, there's even some structural modeling that we do, causal analysis for some of the ad-related products that we do. So everything from like natural language processing to like what is the standard error on this coefficient of this regression model, and we're going to report that in some we really cover the sort of the range of, from like traditional sort of like social science, statistics, hypothesis testing to more computational machine learning kinds of approaches. So.
And you guys have like pretty massive data set, right? A lot of data streaming constantly.
Yeah, I think that it's big data. Yeah.
Get into a lot of conversation about how to define that
Yeah.
too.
We like to call it big data. Yeah.
So with the system that you have and the tools that you're using, are you able to scale well? Like with AWS, are there limitations that are causing
Yeah.
these problems? You mentioned that you guys use R. I assume that's for like a subset of problems versus.
Yeah, and that just depends on whoever is doing the analysis, and I think there's kind of this right now for us. It's most stuff is done in Python, and then sometimes an engineer will pick it up and re-implement it. That's the way things happen if we need to speed up. But yeah, I would say that bottlenecks are one that it's just kind of awkward to run stuff on clusters. The way in which we do, we use EMR a lot, so there's time it takes to like get all the instances spun up, and you may have written some code, but it takes you half an hour to decide whether there's a bug. And you can always spend more time, trying to test it before, but invariably, by the time it gets to the point that it's actually running up on the cloud, there's some stuff that could go wrong. So that really increases the research cycle. And I believe what you guys are doing is, I think potentially a way that we can just kind of run stuff more or less from our desktop and then know very quickly whether something has gone wrong. So definitely that's a bottleneck. I think like a bottleneck too, just maybe more associated with sort of research processes, is that there aren't great tools yet, I think, and you guys are moving in this direction for sure, to ask the question. It's so easy to just like build a model, like I'm just going to shove all the data into this model. I know what my fitness metric is. I know how to do cross-validation. I'm going to feel confident that I'm getting some signal out of the model, and maybe I'm confident enough with the signal that I'm going to push it into production. But then you need to go back. You need to go back to the research phase with it because you want to improve it the next time around, and you're kind of like, I have no idea what this model is doing. Or you get a question from a business person. What exactly is this model doing? You're like, well, there's 20,000 features in this model. Really, do you want me to spend some time trying to figure it out? But it's really important, I think. I think it's always a hedge against putting something into production that doesn't make sense. It's even if you're going to sacrifice some accuracy, try and have something a model that's simple, but it's so easy to sort of get into the computational mode of like just throw a bunch of features in it and away you go. So yeah, so I don't know if that answered your question. But
And also, I mean, with something like AWS does, which can be expensive, how does the cost work out for you guys? Is it economic? Obviously, there's the price of how you implement your own data center stuff,
right?
But at the same time, it's pretty expensive.
It is, and we use the spot market, so that's got its own problems. Sometimes a production, we use the same system for our production processes as we do for sort of ad hoc analysis. So that's for production stuff, the level of service internally for us is not as great as it would be for an outside client. So we can handle sometimes losing the spot market and having to restart the job. It's a different scenario, I assume, different context there. So the costs are, and they just went down. I mean, it's so cheap. I think it's cheap, and getting cheaper, and relative to kind of running your own cloud, I think it's cheaper. There's this cost with spinning everything up, right? I think that's at least from our perspective, the main problem. So I don't see us anytime soon moving away from it, and nothing really has kind of come across my desk that says that there's something else on the horizon that's going to really dramatically change it in the future.
So I'd like to also then fan out the question about bottlenecks and maybe tools and shortcomings for like what all of you guys are seeing in your interaction with customers, in your own use, and the systems that you're building. Obviously, you guys are building stuff to address some of the shortcomings in
common thing, and it even started like an internal joke we had. It was like, everybody bought into this whole big data thing. Everybody built out their storage, bought their Hadoop, got all their, started collecting all this data, and then got to the same point where like, now what? Like, what do we do with it? We have no clue. So like, we started going on this joke where it was just like, how many big data do you have? I have 4. I bought one yesterday, and it really comes down to that. It's like, so we collected all this data, and we can collect it faster, and we're getting better and better and better at collecting this data, and now we have no clue what to do with it. So I think one of the biggest bottlenecks is people who can understand what to do with that data. It's not just data scientists, right? Because it all boils down to, at least the for-profit businesses, it boils down to, are you answering the business question, right? What is the business question? How are you answering it? How are you using this data to answer that question? So the bottleneck that I've seen, and we get a lot of inquiries about it because we provide kind of this idea of, you can throw a lot of algorithms at a problem and see what sticks, is like, what do we do with this data? Like, we have it and we don't know what to do with it.
Yeah, so I think there's a lot of different models. Like the two that come to mind right now. One is definitely this idea of fast iteration being very, very crucial for building good products, building good analytic models. Because I just, first I want to explore the data because I don't know what's in it. And instead of throwing data blindly at some model, it's much better if I look at it and do first pass filtering and say, oh, maybe instead of using, say, zip code, which may not give me, for different problems, zip code may not give me any information about, I don't know, whether the user will like this particular shirt. Maybe it doesn't. But maybe if I use zip code, then it's going to generate 10,000 different new features, and is that worth it? Maybe I have something else that I want to try first. But I don't know. I wouldn't know what to try unless I've been able to interact with the system and look at the data and maybe build a model or two to try it out. And then, so the faster I can do that, the faster I can make progress and settle on the right one in the end. The other one is this, I think a bottleneck is distributed systems, because people kind of go to distributed by default, and I actually don't think that's necessary, because there's a cost to going distributed. Sometimes you need to, but oftentimes at various stages of analysis, especially after the initial feature engineering, feature processing stage, subsequent stages of building a model requires a lot of communication between different threads, and it's multi-threaded, and just a lot of back and forth. So it's much easier. You can build better models on a smaller machine if everything. So on a single machine instead of going distributed. So that's a long-winded way of saying I think people are doing distributed computation by default, and that's not always necessary, and that itself is a bottleneck, because then things get slower and things break, and you don't know why things break.
Maybe you guys have some tools to make it more feasible.
Thank you for finishing my sentence.
So going back to the pricing thing, I think Alice hit like some point right there. Like, really, the biggest cost that you'll ever have is time, right? Losing time is your largest cost by far. No matter how, if you can reduce that time, people will pay any money in the world, because time is the most expensive piece. So that ends up being like, that's what we really care about cost. Like, what's the time loss of these?
Yeah, exactly. So sitting here, I've had time to formulate a very long answer. But I think what we hear from our customers are 3 time costs they have. One is problem definition, and the second is feature engineering, and third is deployment. And all of these have a lot of friction in current process and traditional tools. So problem definition requires someone that has this very heterogeneous knowledge of both business problems as well as data science, so what's necessary and what's feasible. And so that's very challenging. It seems like a new data science project typically has timeframes of months and years of most of the customers that we're talking to, because getting the problem definition right is critical, and that often takes a long period of iteration. And then once you have some type of problem definition, hopefully a concrete goal that you can measure, feature engineering is then where there's a kind of next level of expertise. Most of the time people have their data in databases, and that's completely unsuitable for an actual machine learning approach, right? So there's a significant effort in feature transformation to map it from these like large cardinality categorical and text features and just massive numbers of thousands to millions of columns if it is database data, understanding how to get that into a tractable matrix form that most of the machine learning tools typically accept. So I agree with you. I think a lot of times getting it down to a tractable set on a smaller machine allows you to do that exploration. I think the challenge is that a lot of you can get complex models too quickly a lot of the time. So very simple models that look over all the data is, I think, both approaches have a lot of value, right? So being able to take a large pass over all your data and efficiently understand it. So Hadoop is a big bottleneck right now because it's, so when I was at Yahoo, we used to build logistic regression models on billions of clicks, but this would take hours on large Hadoop clusters. We can do that kind of thing now in memory in minutes, and so that really changes your ability to kind of iteratively explore models. And so that's, like, feature engineering is a large bottleneck in memory. Distributed computing is one of the tools coming to help enable that more quickly. Last piece is deployment. So a lot of, not the top tech companies, still using R and SAS for data science development. And so there's a limit on distributed computing. Those tools have elements of distributed compute, but most people aren't using them. They tend to cost more, be harder to use. And so getting a model from that learning environment where we have it to a kind of integrated with a production deployment system. Often, most of our customers essentially re-implement it, right, in Java or C++ to get it into a production workflow. And so that makes the iteration cycle from problem definition, model development to deploy it in a business process extremely long because they're kicking it over the wall to the development team. It typically also then injects mistakes, and it's an error-prone process. So easing deployment from model to model development to integrated in your business process is another large friction point.
How are we doing on time?
We're right at the top of that.
Okay. So one last question, audience. Feel free to start thinking about questions that you'd like to ask. But what are sort of upcoming tools and maybe research that you guys are really excited about, or you think the community needs to be paying attention to? And I'll run that through all of you guys and then open it up for questions.
We'll start over here.
It's actually the easiest question today. So there's this area of research called auto machine learning that I'm particularly really excited about. It kind of takes a little bit of like from ensemble learning, where it's essentially you want to create a bunch of different hypotheses and like test them all out, and then keep on kind of refining on fit, and you can do that kind of automatically. In this field of auto machine learning, actually one of the main guys is Microsoft Research here, and so we have it kind of locally. Is this idea where you can grab a data set and you can essentially throw thousands of machine learning algorithms at it and kind of see where how that model, like what the results come out. And it's in its early stage, but that could potentially be very, very, very important to the field in general, right? Because now suddenly you have a way of using machines to test out like so many hypotheses at the same time and get a refined model on the other side. So that's particularly an area of research that I'm really excited about.
Yeah, auto ML, I think that was for sure. So exciting areas of research. Auto ML as an example, but I think in general, the area where it's enabling people to use machine learning in an iterative fashion with feedback. So the notion of being able to building better, making machine learning more automated is one, and also making machine learning more interpretable to the end user is another. So tools and research that enable humans to interact better with machine learning models. And there's a number of them. So and also the current tools, of course, GraphLab. People are also
She was
very
paid for
excited
that.
about. People are also very excited about Spark, which is exciting open source development. They put efficient data store on top of Hadoop, on top of a bunch of distributed systems that enable, that help with feature engineering tasks.
I think that, I think I'd kind of like to sort of elaborate on that a little bit, because I think that I think this idea of having, and this is kind of related to the issue of education that you brought up, sort of having the education kind of meet the ease of use with the tool set, because I think fundamentally feature engineering is best done when you have a domain expert and not just a scientist who's just like looking at the stats. So I think that bridging the gap, I think there's going to be a lot more interesting stuff that happens with the accuracy of actual models that are in production. When you take smart people, and you guys have really done, I think, from my perspective, the road of GraphLab is around enabling or empowering engineers, smart people who can code, to be able to make use of machine learning tools. Tableau is something you mentioned, which is, I think, sort of in the direction of enabling analysts to maybe use more machine learning tools. And so, and I'd like to just put a plug in for the data. I think there's a lot more kinds of data that's going to be available for analysis. And I think, especially with obviously the place working with the mobile phone location data, I think there's just so much low-hanging fruit laying around with that data set and that kind of data that can be brought to bear on all sorts of business problems. So I think democratizing the tools and also making many more types of data available, I think, is going to be the big innovation. I think deep learning has been something that's been very exciting, and I'm sure there will continue to be qualitative improvements for certain kinds of problems and the techniques that get used. But even beyond that, I think there's a lot of exciting stuff that's just going to be happening sort of on the ground with people applying machine learning techniques, whether they're more engineers or more analysts to new kinds of business problems.
Yeah, I think the academic response right now is deep learning, but Michael Jordan pretty much skewered that. So I think that's not the savior for actual deployment of these systems in real-world scenarios. More automation, lowering the barrier to entry for companies and people to use the technology. So like Rich, one of his students, works at Context Relevant, so that's a lot of what we're doing is that automation. So we clearly believe that that's the main thing that needs to happen to bring this to new businesses that haven't previously built up the technology and skill sets to do this. And interpretability is the main other. Understanding the sensitivity of the model brings it back as well. And that's something that I think in current state of things, these kind of complex Bayesian networks and DBNs that are popular in that deep learning world really make the interpretability difficult. So because we work in finance, the understanding the model from a regulatory perspective, it's important first for making business decisions, right? So that you can understand what you're doing and that you have some belief in it and that you haven't overfit to what the data you've learned on and that you have some sensibility that you are actually making good predictions about the future that will generate revenue for your business, as opposed to just kind of trusting the data to do the right thing. That's the kind of situation which is likely to lead to fallacy and large problems. So improving the understanding of
okay, but then let's try and have just one per person so we can get through as many as possible. So any questions that people, yeah.
So Elliott, you talked about more data sets becoming available. I'm curious, like, where are these data sets coming from right now? Is it a lot more government data sets, or are big companies like finally starting to find ways to open up what they've been hiding away? Like, what's the
publicly available data sets. I don't know where those are coming from. No, but I think, satellite imagery, lots of companies are opening up APIs and making data available. I mean, 10 years ago, there was no API for geocoding an address that you could call over the web, and now that's basically, you can run a quick analysis on, like, where do, are Starbucks stores nearby a certain zip code or something like that by doing that kind of stuff. And point of interest databases for us is we aggregate a lot of publicly available information about point of interest. What's the open map? OpenStreetMap, sorry, is an amazing growing source of information about geography, right? So, in science, there's like people putting up these ecological data sets that I think are really interesting. Google Images is an amazing publicly available data set to the extent that you can just like download a bunch of images and you take the tags and do your own, build your own image recognition model, right? So I think that that's just a few of the kinds of things that are publicly available. All the time when we're thinking of a new product, I'd say about a half to a quarter of the time there's some kind of publicly available information we can bring to bear to ask the question, is there a viable product here if we, say, try to productionalize the acquisition of information?
It was kind of related to that one. Just to expand upon that, we see these companies really coveting their big troves of data. I mean, we just saw Redfin buy WalkScore, presumably so competitors couldn't have this information. Do we see kind of like a trend towards big companies buying up these different data sources to kind of withhold them from competitors? Will we see the barrier of entry to kind of big data increasing, or with these available sources, do you see it?
Actually, we heard Alice, you work with a lot of people trying to do this kind of stuff with platforms.
So I think companies are a lot of companies are hesitant to make their data publicly available. A few years ago, there's one question of PII, private information, privacy, and personally identifiable. There was a problem with that a few years ago when Microsoft Research tried to publish some main search data, I think, and had to retract it because they realized that you can actually reverse engineer the data. So it's difficult to predict what kind of things people can do with the data that people release that then damage the company who releases them. So then I think in general people are a little more wary about releasing public data that the company collects. With that said, and I don't know about the trend of, I think data is very valuable and useful data is very valuable. There are a number of data sets that are really interesting. Amazon review data, there's a big set of it publicly available through the Stanford Network Analysis Project, snap.stanford.edu. The Netflix data is floating around out there. There's also some large, I'm blanking out on other publicly available large data sets right now. But I do think data is very valuable. So if I'm a startup, I might want to look into data myself.
So going through the trend, so this is actually something going back to like the promise of big data and what we can do. There's a lot of companies who've invested very, very deeply in getting out there like big data, right? And like suddenly they don't know what to do with it. Like they're not getting the return on investment. So actually reselling that data becomes a way of kind of trying to recover that investment that that, you know, like they don't know what to do with it, or they might be able to do with it in the future. We're actually seeing that. So Oracle bought a company, blanking on the name right now, but that's essentially all they do. They just aggregate marketing data across the board, and like people, they will buy it from you, and you can sell your, you know, your company's information, and they aggregate it more, and then they resell it. And so that is a trend that I see is like the people who like failed to be able to monetize themselves on their data now are like looking for a way of recovering their investment.
Yeah, like, I'm iOS developer. I can help to collect data. Like, I'm wondering, like, in general, in your researches, what kind of user information and data would be valuable besides like geolocation and how, and then screening, translation, all these things. Like, what would be your suggestions on collecting data, serving, you know, some use depends on like. I'm working on vehicle, like connected vehicle services. Like if the user may have their phone app installed, maybe like two vehicles are close to each other, they can somehow do something. What kind of data would be interesting and useful, like for your models to do further analysis?
So I know one example, and it's like a really, really simple example. Like retailers, they will pay their weight in gold to know if somebody's a male or a female. Like, simplest thing, I'm serious, like that. Like it gives them so much information as to where to go with that, that just knowing if I use it like from a tweet or from, you know, a purchase, they can just figure out if that person's a male or a female. It's a huge advantage to them because now they can essentially retarget everything that they do. So that's one. In the connected vehicles, I'm kind of like,
More on the mobile.
Yeah, I mean, I think there's a lot of information on the phone, and I think that just besides geolocation, so just knowing the apps that are on the phone, I mean, to your point about knowing whether somebody's male or female, that's not a hard problem if you know the apps that are on the phone. It's probably not that hard, it also, if you know what websites you go to, but that's a little bit harder to do on the phone, right? And more people are using the phone, which is a problem for traditional sort of digital analytics applications. But I think the thing that to always be very cognizant about is privacy. People, it turns out, based on some recent research that was done, covet the location data as being the most sensitive data out there, even beyond their website visitation histories. Just knowing where somebody is at, where somebody's at some point in time is very sensitive information. So I guess to answer your question, and again, I don't know necessarily about your particular application, but there's just, I think, relative to what you're getting off the desktop, there's a potential for much more personally identifiable information on a cell phone. And the privacy issues there are really important. And at place, the way we deal with that is that we effectively pay people for their data.
And maybe aggregate like how many people in certain period driving certain type of vehicle, this kind of.
That's right, aggregating it up. And then making sure that as you develop your product, that the user understands whether information about them in particular is going to be used in some other marketing context, or whether it's aggregated up. And then you're having a policy in place that gives people an assurance that nothing specific about them is going to be used. So that's another whole issue that has to do with the sort of the sphere of the new kinds of data that are being made available.
My question is to Elliott, and I can closely relate with the work that you're doing, since I've myself worked a lot with CDR data from telephone data for a couple of years. And it's the information, the point you fetched was very important, that it's very sensitive, and the kind of analysis you can do with such sensitive data is actually very scary. So what precautions does your company take it in order to, like, do you think that there should be a threshold which you shouldn't cross in order to innovate, like you shouldn't innovate the privacy of people?
Yeah, I mean, from a business perspective, we're being confronted with this question like almost every day. Anytime we talk to a partner, the question is always, okay, is our partner going to be able to identify an individual based on that data? And so there was a couple of recent examples, like we were sort of debugging some location data from one person, and basically you were able to tell that this person was a drug dealer. Because all you needed to do is just see where they went and spent most of the time. Is that we were categorizing a street corner in Detroit as a work location. And then you could go onto Google Maps and look at Street View, and you could see that there was a cinder block there that probably somebody was sitting at for most of the day, selling drugs probably. You know? So absolutely, I don't need to say that. It's obviously a very important point. But in terms of precautions, whenever we share, we do a lot of information sharing with our clients. We always report that aggregate information, but we do a lot of matching, individual matching with some of our clients for our ad attribution product. And you know, we hash device IDs. We don't want to see the actual device ID associated with somebody that we're doing a match for. We are, you know, like I said, we pay people for their information, and we have a very strong policy of just not sharing individual information. So in our products, we have a threshold of, I think it's 100 individuals. We can never report on a metric that has fewer than 100 individuals associated with it. So it's that kind of stuff that we use to protect individuals' privacy.
So if you need a new drug dealer,
first of all, if you were to use my phone and try and figure out if I'm male or female, my 13-year-old daughter downloads her apps on this, as does my 8-year-old son. So you might have a problem thinking I'm schizophrenic or something like that. So
good to know.
That's one thing to consider on phones. But it seems that there's a lot of excitement around, you know, where do I get data? What data is available? What can I do with it? How do I show it? And maybe it's my age or the fact that I'm losing hair, but wouldn't I want to first know what am I trying to do versus let's get all this data and put it in different models and graphs and Tableau, and what's the problem I'm trying to solve? And if I don't have a problem, leave me alone. Or two, if I have a problem I'm trying to solve and you're throwing data at me that I can't use, or I can't control the results of what you're showing me, by telling me that something works with Lightning and I can't do anything about it, it's nice, but stop wasting my time. So where's that part of this whole discussion?
So I'm not 100% sure where the question there is. I agree with you 100% though. I actually say like the trend that I tend to see is like people think that if you aggregate enough data, it'll suddenly start speaking to you. It's just going to start spitting out answers, and like obviously that's not the case. It really comes down to what I think we talked about at the beginning, is like that education. Like you still have to be able to formulate the questions. You still have to have the people who understand the businesses, which is why Tableau has been so successful, or to some degree Excel, where you move that data analysis to the person who understands the business. The person who understands the business can ask the questions, and that ends up becoming like so that's you have a question, now you can go find data to go answer that question. So again, I agree with you. I don't know.
Yeah, I mean, as we talk to customers, there's no lack of questions, especially when you go to the product owners rather than the kind of analytics group, right? The analytics group can sometimes be a little bit more in that paradigm of this is the data we have, what can we say about this data? And the product owners are less interested in that. When we talk directly with business unit owners, they have a litany of questions, and it's more about which one of these can I get answers to quickly with the data